All of you welcome friends. Now today's I'm going to discuss the topic chemical bonding and catalysis, lecture number 2, basic science, course code 22102 for the first year diploma program, first semester I scheme. Myself Mr. M.N. Aher, lecturer in chemistry. Now previous lecture we will discuss start the topic and discuss the term atomicity and electronic theory of valency. Okay. Now the next, that is a chemical bond or formation of chemical bond. Basically the chemical bond is formed atom interact by losing, sharing or gaining of electron so as to acquire the inert configuration. That is the sharing, losing or gaining the electron. This number of electrons are to be lose, share or gain, and these number of electrons are known as the valency electron, and these valency electron indicate the valency. The definition of valency, the valency may be defined as the number of electrons that can lose, gain or share so as to complete its octet and becomes stable. At the time of chemical bond formation or chemical combination, that is the formation of chemical bond, and these bonds are divided into the these bonds are to be classified in different categories. That is the types of chemical bond. The first one is the ionic bond, or it is known as electrovalent bond, covalent bond, coordinate bond, metallic bond, hydrogen bond, hydrogen bond. Okay, the ionic bond or electrovalent bond is formed by transfer of electron, that is a lose or gain of electron. Covalent bond is formed by mutual sharing of electron. Now coordinate bond is formed by one-sided sharing of electron, and metallic bond is formed by delocalization of electron through the metal lattice. Hydrogen bond is formed by when hydrogen atom act as a bridge between two electronegative atoms. Now see the first type, ionic bond or electrovalent bond. The electrovalent bond or ionic bond, that is electrovalent compound or electrovalent compound or ionic compound, is formed by transfer of electron, that is loss or gain of electron. Now an ionic bond is formed by the complete transfer of one or more electron from the outermost energy cell of one atom to outermost energy cell of another dissimilar atom, so that both acquire the stable inert gas configuration. Now the atom lose the electron and acquire the positive charge and becomes positive ions, that is known as cation, and these types of electrovalency are known as positive electrovalency. For example, the sodium, its electronic configuration, atomic number is 11 and its electronic configuration is 281. Means its outermost orbit, that is a 1 electron, and this 1 electron it will be easily lost and form Na plus, and stable electronic configuration, that is 28. That is a loss of 1 electron and it becomes positive charge ion, that is Na plus, sodium ion. For example, magnesium, atomic number is 12 and its electronic configuration is 282, and outermost orbit, that is 2 electron, it will be lost and form Mg++, and its electronic configuration is 28. That is a stable electronic configuration of cation. Now on the other hand, the atom gain the electron and acquire the negative charge and becomes the negative ions, that is anion. And these types of electrovalency are known as the negative electrovalency. This negative electrovalency, that is for example the chlorine. Chlorine, the atomic number is 17 and its electronic configuration is 287. The outermost, in the chlorine atom, the outermost orbit, that is a 7 electron, it required 1 electron and to attain the stability or stable configuration, and chlorine becomes the chloride ions. That is a gain of 1 electron and it becomes the negative charge ion, that is Cl minus, that is anion. Sulfur, the atomic number is 16 and its electronic configuration is 286. It requires the 2 electrons and becomes the stable electronic configuration, that is 288. This sulfur accept or gain the 2 electrons and becomes sulfur S minus minus, that is a negative charge ion. And basically the positive electrovalency and negative electrovalency is formed by loss of electron or gain of electron. That is a loss of electron. These are the metals, and metals having the tendency to lose the electron. The negative electrovalency, generally these are the non-metals, and non-metals having a tendency to gain the electron. Now next, that is a formation of cation and anion. These two oppositely charged ions, that is cation and anion, combine due to the electrostatic force of attraction. That is the electrostatic force of attraction, and to form electrovalent or ionic compound. Thus the electrovalent bond is formed by the force of attraction between the positive ions and negative ions, that is cation and anion. For example, these ions are formed in a previous stage, that is a Na plus and Cl minus. These are the opposite charge ion, and due to this opposite charge ion, that is a chemical combination, and here is form the force of attraction between these two ions and form the NaCl molecules, that is the neutral molecules, and in between the sodium and chloride, that is a bond is formed, and these bonds are known as the ionic bond or electrovalent bond. Okay. For example, the electrovalent compounds, the sodium chloride, one of the examples, sodium chloride, potassium chloride, magnesium oxide, aluminum trichloride, calcium oxide, magnesium chloride, calcium chloride. These are the example of electrovalent compounds, or in this compound, that is the formation of ionic or electrovalent bond. Okay. Now the one of example, that is a formation of magnesium molecules, magnesium oxide molecules. The magnesium oxide molecule is formed by the combination of magnesium atom and oxygen atom. Okay. Now the magnesium atom, its atomic number is 12 and its electronic configuration is 282, means its outermost orbit, that is a 2 electron, and these 2 electrons, that is lends 2 electron, means lose 2 electrons easily, and it becomes the Mg++ ion, that is a stable configuration 2,8, that is a neon configuration, means the magnesium lose 2 electrons to have an octet and becomes Mg++ ions. On the other hand, oxygen, that is the atomic number is 8 and its electronic configuration is 2, 6. Its outermost orbit, that is a 6 valency electron, and it complete the octet, it required the 2 electron. required 2 electron. Okay, the oxygen required 2 electron means it gained 2 electron to have an octet, and it becomes O minus minus, that is oxygen ion. Oxygen ions. Okay, the ionic bond between ion of the opposite charge, the bond is formed in between the opposite charge ion, equal, that is a opposite charge ion result from the electrostatic force of attraction of opposite charge. Now this formation of Mg++ and O-, that is in between these Mg++ and O-, these opposite charge ion, and to create the force of attraction, electrostatic force of attraction, these are come to each other and form the neutral molecules, that is MgO, and in between the magnesium and oxygen, that is a formation of bond. These bonds are known as the ionic bond or electrovalent bond. These are the neutral magnesium oxide. At the time of formation of MgO, the magnesium loses 2 electrons, and therefore its electrovalency is +2. Oxygen gain 2 electrons, and its the electrovalency is -2. Okay. Now the properties of ionic bond or electrovalent bond, or properties of ionic compound or electrovalent compound. In shortly, the ionic bond are formed by lose or gain of electron between these atoms. The bond is formed in between the metal and the non-metal. That is basically metal and non-metal. Ionic bonds are non-directional and extend in all directions, that is a 3-dimensional structure. Ionic compound having a higher melting point and boiling point. Ionic compounds are more soluble in water and insoluble in organic solvent. The ionic compounds are ionized in the fused as well as in a solution state, means that is an aqueous state, and they conduct the electricity. Means the ionic compounds are the good conductor of electricity in fused and aqueous state. These are generally inorganic crystalline compounds. Inorganic crystalline compounds, their binding energy is very strong. That is a binding energy, means bond is a strong due to the attraction of electrostatic force, and they give ionic reaction. Basically, these compounds gives the ionic reaction. Okay, thank you students.